Let x be a uniform random variable in the range -3 to 3. Find the PDF of mod of x. So we have a random variable x which is uniform in the range -3 to 3. Okay, and we have to calculate the PDF of mod of x. So first let's calculate the PDF of x itself. Okay, so what will be the PDF of x? So as we know, for any uniform random variable, the PDF is equal to 1 divided by difference in the ranges. Okay, so here in this case it will be equal to 3 minus -3, that will be equal to 1 by 6. Okay, so now we know everything about the distribution of x, and using this information we have to find out the PDF of mod of x. Okay, so how will you do that? So first observe that y is a function of x which is mod of x. Okay, so first thing you should observe is that y will never take any negative value. Okay, since it's a mod function of x, it will always take positive values. Okay, so if the range of x is from -3 to 3, the range of y will be in the positive direction only. So range of y will be, the minimum value that y can take is 0, and the maximum value that y can take will be equal to 3. So now we know a little bit of information about the distribution of y. Okay, now we have to calculate the PDF of mod of x. So for calculating the PDF of any function of any another random variable, what we do is we first try to calculate the CDF of that function. So in this case, we will first try to calculate the CDF of y. So how do we denote the CDF of y? It's capital Fy at some small y, that is nothing but the probability that y will take some value less than this y, small y. Okay, and since y is equal to mod of x, we can write it as this. Okay, now this will be true, mod of x will be less than equal to y when x will fall in the range -y to +y. You can observe one thing here. Initially we had the problem of calculating some probability of y, but for calculating that we would need the distribution of y. Okay, and we don't know the distribution of y. Our goal is to calculate the distribution, right? So what we do is we cleverly convert this problem of calculating the probability of y into a problem of calculating some probability of x. And since we already know everything about the distribution of x, okay, we can immediately calculate this probability. So you will be able to calculate this probability by integrating the PDF of x from -y to +y. Okay, so PDF of x is just 1 by 6 dx. When you integrate it, you will get x by 6 from -y to +y. Okay, which will be equal to 2y by 6, which is eventually equal to y by 3. So this is the CDF of y. When we differentiate the CDF, we get the PDF of y equal to 1 by. So this is the PDF of y. Okay, so since it does not depend on y, it means that it's uniform in its range. Okay, and what's the range? Range is from 0 to 3. Okay, so we can say that y has uniform distribution in the range 0 to 3, which is equal to 1 by 3. Okay, which corresponds to the second option here. Okay, now let's do one more thing. Okay, now let's compare the PDF of x with the PDF of y. Okay, so we saw that the PDF of x was equal to 1 by 6 and PDF of y came out to be 2 times the PDF of x. Okay, so why is that? So let's try to understand this problem graphically. Okay, so here is just the plot of two PDF of x and PDF of mod of x that I have drawn using matplotlib. Okay, so this is for x, this is the PDF of x, and this is the PDF of mod of x. Okay, x in the range -3 to 3. you can observe that when you try to calculate the probability of any value of y, okay, since y can take values only in the positive range, okay, so suppose probability that y takes value some any specific value y equals 1, so it will definitely be equal to when mod of x will be equal to 1, and it will be equal to the probability that x takes value -1 or x takes value 1. Okay, so it is true for any value of y. Okay, any value that y can take, okay, it will correspond to two values of y. Okay, so since there is a mapping from x to y, there is a mapping from x to y. Okay, so there will be two values of x for which y will take a particular value. So y has a PDF double of the x, and it has a shrinked range, okay, which is in the range 0 to 3.